Alright, in class we have been talking about friction in all kinds of ways, so now we're going to get into some specifics about it. So, we've already talked about this. Friction is a force, and it always opposes the motion of the object, right? So it points opposite of whatever direction the object is moving. Usually in this class that also happens to be opposite of the force applied, but like say in the case of something falling through the air, it would actually point opposite of the force of gravity, things like that. But always opposite of the motion. There are several types of friction, and the one we've been dealing with most in class is sliding friction, where you have two objects sliding past each other, so like something sliding on a surface. All right? That friction is caused by microscopic irregularities at the touching point of the two surfaces. Okay? The rougher a surface is, the more friction there is. The fewer irregularities, so the smoother the surface is, the less friction there is. Okay? There's also rolling friction, which would be, a ball rolling. Rolling friction is very similar to sliding friction. We really don't distinguish the two in here. Then there's fluid friction, which is known as air resistance, and that would be what causes friction, say when you're falling through the sky, that sort of thing. So our focus will be primarily on sliding friction, and this is how you would calculate the specific frictional force if you know enough information about the surface that the thing is sliding on. Okay? So the friction force acting on an object increases as the normal force increases. Alright? So, and I know the letters are all capitalized, but remember this is F, Fn. Alright. And there is for every surface, there is a specific correlation, kind of like a constant, that determines the relationship between the force of friction and the normal force of the object. Alright, because normal force only exists if you're on a surface. Okay? So that's why it's the normal force that indicates friction. Now, in this class, we work specifically with things on a flat surface, all right? Which, in that case, whenever something's flat on a surface, we have the force of gravity pointing down, normal force pointing up, and those two are equal to each other. So you can kind of think of it as the equation is more like the force of friction is equal to this coefficient times the force of gravity, which means this equation is going to come in very handy for finding friction. Okay? Now, keep in mind, this is the equation that I'm going to give you on a test. You have to remember this part, that when we're on a flat surface, normal force equals force of gravity. Okay? So, that funky letter, the coefficient, it's called mu. It's the Greek letter for m, and that is known as the coefficient of friction. All right? Mu is dependent on two things. The roughness of the surface, so like if you have a book sliding on a table, that would be the table. All right? And then the roughness of the object moving, that's the book. So mu is determined by those microscopic irregularities between the two things sliding on each other. The force of friction, however, is dependent not only on mu. A higher friction coefficient is going to create more friction, but it's also dependent on the normal force, or in this class, the weight of the object. Heavier things experience more friction, right? Because that increases your normal force. So keep these couple of things separate, all right? Mu is not dependent on friction. Sorry about that. Mu is dependent on the surfaces. Friction, however, is dependent on mu and weight of the object. So, real quick, not really whiteboard questions, just questions in general. See if you can answer these. I'll go over the answers in a second. But if you can answer this stuff, that means you're kind of picking up on the basic information out of this. So, mu, hopefully you said that's the coefficient of friction. Air resistance is fluid friction. All right, friction is dependent on mu and normal force, because remember, mu is dependent on the surfaces. And then if you increase the weight of an object, that's going to increase your normal force and therefore increase your friction. Okay? So what type of relationship is that, if you recall? Hopefully you're saying that is a direct relationship. Because if you increase one, it causes the other to increase. Okay? So, how you will use this equation in class. Again, most of the time I'm not going to sit there and be really obvious with your forces. You have to work for figuring things out. So here we have a 50 kilogram box experiencing a frictional force of 200 newtons. What is the coefficient of friction? All right, so we know our mass is 50 kilograms. We know F of F is 200 newtons. All right, to find mu, that's our F of F equals mu times F of N, which if we divide by the normal force, mu is equal to your force of friction divided by your normal force. First it appears, oh wait, I don't know this, but let's draw a diagram. We know that this box is 50 kilograms, which means the force of gravity is going to be 50 times 10, which equals 500 newtons, which also means that our normal force is 500 newtons. So now we know F of N is 500 newtons. Okay, so that means if we take these back over here, our force of friction is going to be 200 over 500 for the normal force, which means mu is 0.4. Now, I know I didn't point this out explicitly before. Mu is the one time you can get away with leaving off units. No units. Because if you look at this, it's 200 newtons divided by 500 newtons. If you divide anything by itself, it cancels out. So the units disappear. So mu is the only thing in this class where you'll ever be able to just forget about units. Okay? It's also one of those things where you want to make sure you don't all of a sudden tack units on there because they don't belong there. The coefficient of friction is unitless. So one more example problem. We have a 35 kilogram box sliding on a table. Coefficient of friction is 0.25. What is the force of friction? So we have mu equals 0.25. Mass equals 35 kilograms. All right. And we know F of F is equal to mu times normal force. And once again, we aren't given normal force, but we know mass is 35 kilograms. So according to F of G equals M times G. Sorry for all the bells. This is going to be 350 newtons for our force of gravity. All right. Which then means our normal force is 350 newtons. So N equals 350 newtons. Now we can take these two pieces and plug them in. We'll have 0.25 times 350, which is F equals 87.5, and it's force of friction, so this will have units of newtons. Okay, so those are the types of problems that we'll start with. Eventually we'll get back into first law diagrams and using this to make sure all of our pieces are accounted for. So please make sure you do the online assignment and I will see you in class.